Calculus video 39, the derivatives of inverse tangent and inverse secant. And maybe just for inverse tangent of x and inverse secant of x. Okay, the derivatives of inverse tangent of x and inverse secant of x. First, recall we did this in the last video with inverse sine of x. We do the exact same process with inverse tangent of x and inverse secant of x. So let me, in a short time here, recap how we did this last time. What we want to know is we want the derivative of the inverse sine of x. So we start off with, let's let theta, some angle, equal the inverse sine of x. Remember that the inverse trig functions get put in a value and you get out an angle. So theta here is an angle. Since theta is equal to the inverse sine of x, we get that the sine of that angle theta must be x. That's properties of inverses. From there, we can draw a triangle, a right triangle in particular. Pick an angle theta. I like that one. And since sine of theta is x, or x over 1, that's the opposite x over the hypotenuse 1. Then we did the Pythagorean theorem. A squared plus x squared is equal to 1 squared. We solved for a being this side, this adjacent side down here. And we got the square root of 1 minus x squared. Check the old video if you don't remember how to do that. Alright, so now we have this set up. Then we'll start with this sine theta is equal to x, this part right here. We'll rewrite that. Sine theta is equal to x. And we'll take the derivative of both sides with respect to x. Now because theta is not x, when you take the derivative with respect to x of sine theta, you have to do the chain rule. So the derivative of sine theta is cosine theta times d theta dx, and that is equal to the derivative of x, which is 1. Solving for d theta dx, we get d theta dx is 1 over the cosine of theta. And going back to my triangle now, cosine of theta, cosine is adjacent over hypotenuse, so adjacent over hypotenuse, we have cosine theta is adjacent square root of 1 minus x squared over the hypotenuse of 1. Dividing by 1 doesn't change anything. And we get the fact that the derivative of theta with respect to x is 1 over the square root of 1 minus x squared. But if you go back up, since theta is the inverse sine of x, the derivative of theta with respect to x must be equal to the derivative of the inverse sine of x. Therefore, when we found the derivative of theta with respect to x, we have also found the derivative of the inverse sine of x, which is 1 over the square root of 1 minus x squared. Done. All right. That process right there. We're going to repeat that process, but now we're going to do it for inverse tangent of x, and then we're going to go with inverse secant of x. So what is the derivative of the inverse tangent of x? Equals question mark. If you feel like you have that process down that we just did, feel free to pause the video and see if you can work through this one on your own. Or if you're halfway through, right, like, okay, I can get it from here on out, pause the video, see if you can work through it on your own. We're going to start with the fact that the inverse tangent of x puts in a value, gets out an angle, so therefore some angle theta must be equal to the inverse tangent of x. And in the end, what we're going to find is d theta dx, knowing that d theta dx is the same thing as d inverse tangent of x dx. All right? In other words, if I took the derivative of this side, that must be equal to the derivative of this side. We're going to find this in the problem, which then we'll replace with finding the right-hand side, the derivative of the inverse tangent. Okay? Theta is equal to the inverse tangent of x, therefore tangent of theta must be x. Or maybe you think of that as x over 1. From there, you can draw a triangle. Here's theta, there's the right angle. Tangent. Now, tangent is the opposite over the adjacent. So opposite is x, adjacent is 1. Let's call the hypotenuse, I don't know, c for a moment. We see that 1 squared plus x squared is equal to c squared. Let's see, 1 plus x squared is equal to c squared. So solving for c, we square root both sides. C is technically plus or minus the square root of 1 plus x squared. However, this is a length, so we'll go with the positive version, plus square root 1 plus x squared. So that's c. So I'm going to erase my c. I'm going to put that in with square root 1 plus x squared as the hypotenuse. That just comes from the Pythagorean theorem. All right, now we're going to go back to this tangent theta equals x. We're going to rewrite it, tangent theta equals x, and we'll take the derivative of both sides implicitly. In other words, the derivative of the tangent of theta is equal to the derivative of x. The derivative of tangent theta, if you remember the derivative of tangent, is secant squared of theta, but since theta is not x, we have to chain rule multiply by d theta dx, is equal to the derivative of x, which is just 1. Right? Therefore, solving for d theta dx is equal to 1 over the secant squared of theta, or 1 divided by secant squared. 1 divided by secant squared is the same thing as cosine squared of theta. Okay, so what is the cosine squared of theta? Well, what's the cosine? Here's our angle theta. Go back to the triangle. Cosine of theta is the adjacent over the hypotenuse, so it's 1 over the square root of 1 plus x squared, but all that is being squared. This is equal to cosine theta, 1 over square root 1 plus x squared. That's cosine theta, but this is cosine squared theta, so we have to square that. Square of 1 is 1. When you square the square root, you just get what's inside, 1 plus x squared, and we're done. The derivative of theta with respect to x is 1 over 1 plus x squared. Therefore, the derivative of the inverse tangent of x is also 1 over 1 plus x squared. Proven. Okay, so far we have 2. We have that the derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. And the derivative of the inverse tangent of x, 1 over 1 plus x squared. You need to know them both. Need to know them both. All right, let's go to our third one. What is the derivative of the inverse secant of x? The proof here, the process is exactly the same as what we did in the last one. All right, we'll start off with, well, let theta, some angle, equal inverse secant of x. We'll rewrite, we'll do the triangle. Pause the video, see if you can work this one out on your own before I go through it. Okay, let's try it out. So if theta is the inverse secant of x, that means that the secant of theta must equal x, or x over 1. Secant of theta is equal to x. Triangle, theta, right triangle, secant. Now secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant must be hypotenuse x over adjacent 1. And then let's call this, say, b over here for now. Pythagorean theorem says that 1 squared plus b squared is equal to x squared. Solving for b, I get b squared equals x squared minus 1, or b is equal to plus or minus the square root of x squared minus 1. Since we're dealing with the length here, let's just call it the square root of x squared minus 1. So I'm erasing b, rewriting square root of x squared minus 1. So that is the length of the opposite side for theta. Okay. Once we have our triangle built, we'll go back, we'll use the secant theta is equal to x. So just kind of rewriting it over here. Secant theta equals x, and we'll take the derivative of both sides. What is the derivative of secant theta? What is the derivative of x? The derivative of secant theta is secant theta, tan theta, and then because theta is not x, times chain rule d theta dx is equal to 1. Solving for d theta dx, I get d theta dx is equal to 1 over secant theta tangent theta. And now we'll just go back to our triangle, plug in whatever secant theta is, plug in whatever tangent theta is, multiply those together, and get my answer. All right, secant theta, don't work too hard on that one. We already have it right here. Secant theta is equal to x. So I can replace secant theta with x. Okay, tangent theta, however, we'll go back to the triangle. Here's theta. Tangent is the opposite over the adjacent. So tangent is the square root of x squared minus 1 over 1, or just the square root of x squared minus 1. And that seems to be, then we're done, seems to be almost done. The derivative of inverse secant of x appears to be 1 over x square root x squared minus 1. And it is, except for one little thing here. If you remember the graph of inverse secant, it looks something like this. There was a horizontal asymptote here at pi over 2. Here's at 1 and negative 1. Negative 1's up here at pi, and it kind of went down like this. And then at 1, 0, went like this. Okay. At any point on this graph, pick any point you want, notice that the slope is positive. The slope's always positive for the inverse secant. But if you were to, say, plug in an x value of negative 2 and put that negative 2 into the x, or really all of the x's, you would see that when it's inside the square root there, if I plugged in negative 2 here, that's square, that's 4, positive 4 minus 1 is 3, that's squared, that's a positive number, that's no problem. But if I were to plug a negative 2 in here, that would make it negative, and I'd actually end up with a negative slope, and that's not okay. So, in order to make sure that the slope is always positive, which it should be for the inverse secant, we can't just leave it x here. We need that x to always be positive, therefore we put it in absolute value. And we get this. The derivative of the inverse secant of x is equal to 1 over the absolute value of x times the square root of x squared minus 1. And that's our third one. All right, so that's it. Let's write these down so we have it in a nice, organized fashion. Let's do the derivatives of inverse trig functions. Okay, we have that the derivative of the inverse sine of x is equal to 1 over square root 1 minus x squared. But oftentimes we're not just taking the derivative of inverse sine of x. That x there is often an entire function of its own, right? Kind of like when we did the natural log of x was 1 over x. If that's not what we typically do, it's more like the natural log of 2x squared minus 5x plus 1, right? We end up with u prime over u. The same thing is going to occur here. We don't just want the derivative of the inverse sine of x. We want the derivative of the inverse sine of u, where u may be some function of x. Okay. The answer is it's the same thing. We just, because we're taking the derivative of u now as opposed to x, we then have to multiply it by du dx, or u prime, using the chain rule. So I'm going to write something that I'm going to erase it. It's 1 over square root 1 minus u squared times u prime, according to the chain rule. But much like with the derivative of the logarithm, the natural log, instead of 1 over u times u prime, we rewrote that as u prime over u. Right? And so we'll just take this u prime, we'll bring it up to the numerator here. And so what we often think about it is the derivative of the inverse sine of u is u prime over square root 1 minus u squared. And honestly, that's the one that I want you to remember when you're thinking inverse sine of u. The derivative of inverse sine of u is u prime over square root 1 minus u squared. All right. Now, we didn't go through the proof of the inverse cosine. You're more than welcome to. It's the exact same idea as the proof of the inverse sine. But what you're going to get is the derivative of inverse cosine is exactly the negative version of the derivative of inverse sine. So the derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. And the derivative of inverse cosine of u is negative u prime over square root 1 minus u squared. Out of all these four, the derivative of inverse sine of u, that's the one I want you to remember. The derivative of inverse cosine of u is just the negative version of that. Okay? Let's go on to the derivative of inverse tangent. The derivative of inverse tangent of x, we'll use x's first, is 1 over 1 plus x squared. But the one I want you to know is this one. The derivative of inverse tangent of some function u is u prime over 1 plus u squared. That's the one I want you to know. Similarly, the derivative of the inverse cotangent of x is negative 1 over 1 plus x squared. Whereas the derivative of the inverse cotangent of u is negative u prime over 1 plus u squared. Okay, so in other words, the derivative of inverse cotangent of u is the negative version of the derivative of inverse tangent of u. We use the derivative of inverse tangent of u much more often. It's the positive version. Okay, so out of the four, know that one. The one that started there. And finally, we have the derivative of the inverse secant of x is 1 over absolute value of x square root x squared minus 1. But more importantly, the derivative of the inverse secant of u is u prime over absolute value of u square root u squared minus 1. Again, that's the one I want you to know. We could find then the derivative of inverse cosecant of x as negative 1 over absolute value of x square root x squared minus 1. Remember that the slope of the inverse secant is always negative. Whereas, you just extend that, the derivative of the cosecant inverse of u, negative u prime over absolute value of u square root u squared minus 1. But again, the inverse secant of u derivative, that's the one I want you to know. Okay, so know them, write them down, make a Quizlet, make your own flashcards, but we need to know the derivative of inverse sine of u, the derivative of inverse tangent of u, and the derivative of inverse secant u.